Thank you very much, Dagmar. And I want to thank the committee for inviting me and giving me this opportunity to tell you about my research. I'm always happy to step outside the usual audience and talk about what I do. Everything we do leaves a trace on our mind and on our brain. In fact, there's an old 17th century conception of the brain that says it's kind of like a beach, just when it's not too dry and not too wet. So imagine a beach where the tide has just gone out and a bird walks across the beach and leaves its footprints in the sand. That's an odd metaphor for the brain, but it's not a bad metaphor for my main point. Everything we do, everything we learn, everything we become skilled at leaves its trace on our mind and in our brain. Now, there's some research that shows what kinds of things do this. So, behavioral changes. People who spend or squander large parts of their lives playing video games actually become better than people who don't engage in such activities at things like the rapid perceptual and motor coordination. Architects are better than non-architects at a variety of visual spatial tasks. These changes are also found in the actual structure of our brains. So, London taxi drivers, to get a license, have to pass a test called the knowledge, in which they have to commit to memory every street and close and alleyway in Greater London. It turns out that the part of the brain that's responsible for spatial navigation, it's a little bit of the hippocampus deep inside the brain, is larger in London taxi drivers than in the rest of the population. And finally, string musicians make all of their sound from these four fingers of the left hand. And if you look at the bit of the brain that controls those four fingers, it's larger in professional string musicians. So everything we do changes our brain. And what I'm going to try to persuade you of today is that bilingualism is a very special case of an experience that changes our brain. It's special because it's something we all have access to, and it's special because of how profound it is. So let's just compare these experiences that I've told you about to bilingualism. So who has these experiences? Well, it's possible that people who already have very good visual spatial skills choose to become architects. But bilinguals don't self-select. Usually people become bilingual because life made them so, not because it was a choice. How broad is the impact? I told you that, for example, these video game players, wherever they are, they're better at things that look a lot like playing video games. That's not very surprising. But for bilingualism, this is a linguistic experience, and we have the opportunity to see if it reaches beyond the exact activity that it engages. And finally, how extensive is it? If you're a professional string musician, you may practice 4 hours a day, 5 hours a day. How many hours a day do you speak? All of them. So in terms of how intense and sustained the activity is, nothing we do comes close. So for all these reasons, I'm going to suggest that bilingualism is the ideal experience in which to examine this notion that what we do changes our minds and brains. Well, what do I mean by bilingual? In psychology, we have this kind of approach to research. You take a bunch of subjects, usually people who are taking Psych 100 and are required to spend 6 hours being a subject in a psychology experiment, and then you toss them into two groups, boys, girls, old people, young people, whatever. The problem is bilingualism is not categorical. How do you toss people into two groups and determine whether they're bilingual? How many in this audience believe they are bilingual? How many believe they are monolingual? How many did not raise their hand? See, okay? It's a continuum. What you really want to know is, well, how bilingual does she mean? You know, I can speak Italian, but... So on the one end, really bilingual is clear. It's a kind of a two-headed monster. You have two lives, two brains, two languages. And on the other end, it's also clear. Someone who hasn't got the slightest idea that there are other languages and words exist in them. But I would suggest that most people really are somewhere in the middle. And it turns out that how bilingual you are matters greatly because it's a continuum. And so if experience is spread out on a continuum, then the more you have of that experience, the more outcome we expect. The more you practice the violin, the better you can play. And so bilingualism is like that too. It isn't a categorical variable. And that's a very hard idea for psychological research. All right, so let's get to it. So what do we know about bilingualism? Here's how the mind works. You see something and you conceptually label it. If you're bilingual, you can give it two labels. Now what happens is that the bilingual mind simultaneously generates both labels, creating conflict. What do I say? Dog, chien, what do I do? We have in our brains, in our minds, a system that is designed to handle conflict. That is its job. It's called the executive control system. So it says conflict, I'm on the job, and it comes in and adjudicates between these jointly activated linguistic options. And the whole story that I'm going to tell you is based on that little cartoon with the implication that because that executive control system gets plopped in every time a bilingual wants to say anything at all, that executive control system is changed. That is the consequence of bilingualism. So here's a picture that shows the same information in a different way. You have some kind of a representation of a language somewhere in your mind. If you're bilingual, you have two of them, and they're both jointly activated. Now, it's also the case, and I'm not going to talk about this today, but I'll just insert it into this diagram. It's also the case that bilinguals tend to know fewer words in each language than monolinguals. So there's some gaps. We have a bit of reduced choice. But crucially, there is all of this substantial overlap. So we have conflict. And that conflict leads to two implications. There is reduced lexical retrieval. I'm not going to talk about that today. There is enhanced executive control, and that's what I'll focus on. So because the system requires executive control is modified by bilingualism. Now, our brains have specialized areas whose job it is to do different things. But it's not phrenology. It's not that there's a bit here that does one thing and a bit there that does another thing. The way the brain actually works is that there's systems or networks of connections that together carry out functions. And those networks themselves can become rewired or reconfigured. So this is a picture of a typical executive control network. It has a lot of activity right in the front part of the brain, which is the most important part of the brain. It is connected to things at the back of the brain where more specific knowledge is. But it's this entire network that is the executive control network. And what I will argue is that using that network every time you want to say something for resolving language conflict modifies those connections, so the network looks different. All right. I want to take a little detour and tell you what I mean by the executive control system. It essentially has three things it's responsible for. The first is called inhibition, or inhibition and selection. What does that mean? Well, you walk into a noisy bar looking for Martha, and you are bombarded with lights and sounds and visions and people. And in order to carry out your goal of finding one individual in that mess, you need to inhibit, select, focus. That's job one of the executive control system. The second thing it's responsible for, multitasking. And this is something we are always all familiar with in our modern world. How can we divide our attention so we can do more than one thing at a time, which has become a normal expectation in our lives, I think. And the third thing that the executive control system does is working memory. That's when you hold things in mind and then move them around without forgetting what they were in the first place. Okay? So that's the executive control system. And all of those jobs are carried out by that network that I showed you. We've studied this system across the lifespan. And now a couple of things to note. First, the executive control system is the last cognitive system in the brain to develop. That is, the front part of the brain, where those front nodes were, develops that fatty myelin connecting tissue quite late. In fact, the development of that system goes right into adolescence. So until that front part of the system is all covered with myelin, the executive control system doesn't work very well. So if you would ask, for example, a 4-year-old, Jennifer, why can't you just sit still and concentrate? What Jennifer should really say is, it's not my fault. My prefrontal cortex has not yet been fully myelinated. I can't sit still. And until it is, that system is not working. So this system evolves through childhood, peaks in young adulthood, and then begins to decline. So it's the cognitive system that we have available to us for the shortest amount of time. If there's some way of making it stronger or last longer, this would be pretty important, and that's what I maintain bilingualism does. Now, we've looked at people at all of these ages that I have shown you, doing various kinds of executive control tasks, all sorts of different things tapping into those three components. And in general, what we find is that bilinguals perform these tasks better than monolinguals. That's pretty well the case at all of the ages. But I think more interestingly, that if you look at their brains, if you use functional magnetic resonant imaging, you see what networks they're engaging in their brains. The bilinguals are using slightly different networks. And I think it's that shift in the way the network is configured that makes their performance better. Now, I'm going to show you what I mean. So this is an experiment that has been around since 1935. Every introductory psych textbook has it. I bet many of you have heard of it, seen it. You think you know what's coming, but I bet you've never actually done it. So this is the audience participation part of the talk. You really have to do this. I'm going to show you words, and you have to tell me the color of the ink out loud as fast as you can, and you really have to do this, okay? Be good, all right? Name the... Okay, audience 1, Ellen, no score. There we go. Okay, you ready? Out loud as fast as you can.
Red, blue, green,
Okay? So what happens is that if the word, you're all literate, you cannot help read the word. Doesn't matter. You read the word because it's there. So what's happening is that on those last 3 items, the word that you read very quickly is different from what you know you have to do, and you have conflict. So we can look at that conflict. It's called the Stroop effect. And I'm going to actually show you some data here. There's only 2 slides with real data, and here's one of them. So how much longer does it take you to give the right answer? And none of you gave the right answer. But if you were really going to give me the right answer to those last 3 slides, how much longer does it take on average, okay? So we did 2 studies. They're younger and older, monolinguals and bilinguals. Now, the solid lines are young adults. The hashed lines are older adults. This is how much longer it takes. So a longer cost here is worse performance. So for younger adults and older adults, the monolinguals take significantly longer than the bilinguals. We did the experiment again with a different group and got the same results. So this is what I mean by a bilingual advantage in executive control. How does this relate to what I told you? So remember I said this is what happens in a bilingual mind. There's 2 possible labels for one simple concept. They're both active, they create conflict. In the example I just showed you, you see a stimulus like that, and you immediately generate 2 possible answers. And the task requires that you give one of them and ignore the other. Just as if you're speaking now in English and you want to refer to your beagle, you would have to use this label and not this label. So in some sense, being bilingual is like being in a constant Stroop test. Now, there's just one other example. This is a study we did with children, just to show you a different way of demonstrating the same thing. So we did this actually 3 times with 6-year-old children. I'm just going to show you one graph. Half of them are monolingual, half are bilingual. We match them on a lot of things. So they're looking at a computer screen and they see either a letter H or a letter S, and they're told, press this key if it's an H, press this key if it's an S. And they sit there and they do that as fast as they can. And again, the monolingual and the bilingual children do this perfectly and identically. So now we change the task a bit, and the stimuli look like this. For example, they'll see stimuli like this or stimuli like this. And again, they're told press one key if it's an H and the other key if it's an S. And they're told whether to decide whether to look at the big letter or the little letters. This is all counterbalanced. And what happens, again, is the monolingual children take longer to perform the task. The conflict between 2 possible responses is resolved more rapidly, more efficiently by bilingual children. So that's a taste of what we get. I've shown you data from children, young adults, and older adults on a couple of different tasks. So let's look at why these differences come about. I'm just going to tell you the story again, but try to put it together more in terms of what's happening in the brain. Because there is joint activation of the 2 languages for a bilingual, there's a constant need to manage attention and resolve conflict, and that invokes the executive control system. As a consequence of being brought online for managing this linguistic conflict, the executive control system rewires, and specifically what it does, it connects itself up more deeply into the language areas. So it has branches of that network that include language areas, so it becomes a broader, more robust network. And the consequence of all this is that it's a more efficient system, and that's why we see these performance differences in bilinguals across the lifespan. Now, why is this important? It's particularly important for aging. Like everything, the executive control system declines with age. Well, everything does. We're not surprised. But you may be surprised to know that the decline begins at 30. So we really have limited use of this most important system. But anything we do to keep that system engaged keeps it young and healthy. And as all of these functions become more effortful, any kind of activity that keeps that executive control system in use keeps it more efficient. Now, all of the research I've shown you so far has been with typically developing children, smart young York University students for the young adults, and healthy older adults for aging. So a pretty ideal and privileged population. But not all aging is as fortunate. What happens when aging is accompanied by impairment, and particularly when cognitive decline is not going on the normal trajectory but includes dementia? Now, it's almost an odd question to ask. I've just been trying to persuade you that the main effect of bilingualism is on the executive control system that does all of those things I've demonstrated. But the main complaint of dementia is a memory failure. And I haven't said anything about memory. And in fact, there's really very little reason to believe that on average bilinguals have better memory than monolinguals. So why would bilingualism have an impact on protection against dementia? We decided to look at this question. Now, in the first study, the first two studies I'm going to show you, we just wanted to see if the onset of dementia, in terms of symptomology, in terms of failures to perform ordinary activities, was in any sense different for monolinguals or bilinguals. So we did two studies by examining clinical patient records at Baycrest Hospital. In the first study, we had about 100 patients in each of the monolingual and bilingual groups, and 2/3 of them had been diagnosed with Alzheimer's disease, and the other 1/3 with various dementias. And in the study 2, we went back to a new group at the same clinic, and this time we only selected patients who had been diagnosed with Alzheimer's disease. We just wanted to know when their families noticed something was wrong. Here's the background data for the first study. We have, those are the numbers. Years duration is the length of time between the family noted something. This is when they're in the clinic and the neurologist says, when did you first notice something was wrong? And typically they say 3-4 years ago, and everybody says exactly the same. Now, years of education is somewhat interesting, but I caution you not to overinterpret it. One of the experiences that has known benefits to protect against cognitive decline is formal education. The more years of formal education you have, the more likely you are to remain cognitively able for longer. So it should be that with more formal education, you will have a later onset. In this sample, it's actually the monolinguals who have more formal education. That's a significant difference. So we would expect them to be older when the symptoms appear. But again, I would not overinterpret those data. MMSE is a score out of 30 that gives a very general level of cognitive functioning. Anything less than 26 is impaired, 22 or less is dementia, and you can see they're exactly the same level. So here's two groups of patients. They look the same. How old were they when their symptoms of dementia first appeared? And you can see that the bilinguals were 4 and a bit years older. That is massively significant. So a very substantial delay of time before symptoms were noticed. Now, it's a dramatic result, so we just did the whole experiment again with a new group. These are only Alzheimer's patients now, and you'll see that all of these numbers look really similar. And again, see, I think this is a demographic thing because a lot of the bilingual patients at Baycrest were in Europe during the war when they should have been in high school. So that curtailed their formal education. So in the second group, here are the ages, and you can see, again, the bilinguals are substantially older. So in a sample of about 400 patients, we have a very robust delay in the onset of symptoms. Now, I'm going to take those numbers and just put them on a graph for you so I can come back to it. These numbers now are the numbers I just showed you, but what I'm plotting here is not the onset of symptoms, but the age of diagnosis. So this is how old the monolinguals and bilinguals were when they went to the clinic and were diagnosed with their Alzheimer's disease, okay? Now, often before someone presents with full-blown Alzheimer's disease, there's a preclinical stage called mild cognitive impairment. This is when things are starting to go a little bit off the rails, but a lot is still okay. So it's a transitional stage. And there are, in fact, formulas for conversion, the rate at which or the proportion of which MCI patients convert to Alzheimer's disease. So we wanted to just back step a bit and see if anything is happening at that preclinical stage. Now, the diagnosis is that the MMSE score that I showed you is normal. So these people are getting 28 or higher on MMSE, so they're functioning really well. But they have either a memory problem or a memory and a cognitive problem. And they progress to AD. Now, there are two subtypes of MCI. One is called single domain, and one is called multiple domain. Single domain MCI are people who only suffer memory problems. Everything else is fine, but they have memory failures. Multiple domain suffer memory problems plus something else. And here's the thing. That something else is almost always executive control. So the difference between single domain and multi-domain is that for single domain, there are only complaints about memory, and for multiple domain, there are complaints about memory plus failures of executive control. So we found these patients. The numbers are not equal because these are very hard patients to find. They're screened on many, many different dimensions. And again, we just want to know how old they are when they're diagnosed. Now I'm looking at when they're actually in the clinic and they're diagnosed. Those are the data I showed you a minute ago. Now let's look at the single domain MCI patients. They only have memory problems. They are on the road to Alzheimer's disease. This is a preclinical form of Alzheimer's disease. And if we look at how old they were, we see exactly the same pattern. The bilinguals are significantly older than the monolinguals when they succumb to these memory failures. What about multiple domain? They have memory failure plus executive control failure. No bilingual advantage. It's gone. And the reason we argue is because we've knocked out their crutch, the thing they have been relying on to deal with failing memory has been taken away. So their an enhanced executive control system has been impaired by multiple domain MCI, and they have nothing left with which to compensate for encroaching memory failures. All right, and finally, and this is the last part of the argument that I'm going to show you, we want to understand how this protection works. So we've seen now in a few studies that bilinguals are successful in holding off memory impairments and Alzheimer's disease as long as the executive control system is intact. What does the brain look like when this is happening? Now, there's a larger field of study called cognitive reserve, and this is all the stuff you hear about: do crossword puzzles and join a group and read books and attend Saturday lectures. It's all good for your brain. So the idea of cognitive reserve is well established, but the mechanism for cognitive reserve is highly controversial. There's two leading schools of thought. One notion is that what cognitive reserve does and what bilingualism does is, in a sense, inoculate your brain. So the brain becomes more robust. The brain is more resilient. So when all of those beta amyloid plaques start to work their way into your gray matter tissue, the enhanced bilingual brain is fortified and can resist like a vaccine. So the brain resists. On this view, the reason bilinguals are older when they show symptoms and then become diagnosed is because their brain has actually held back the floodgates, okay? That's one view. But there's an alternative view that says, well, look, you know, these beta amyloid proteins, they're going to do whatever they do. So they actually begin their entanglements at the same age. They don't care how many languages you speak. But if you're bilingual, you have a means of overriding the damage that's being inflicted by these disease-causing proteins, compensating probably through the executive control system. So that's the compensation story about cognitive reserve. Now, the nice thing is that these two stories make very different predictions about what the brain looks like. And it's this: if you have two individuals who are identical age, identical disease severity, identical diagnosis, identical everything, except one of them is bilingual, if you look in their brains, the first idea that the brains are inoculated predicts that their brains will look exactly the same. By the time they've reached the same stage of disease, their brains look like whatever it looks like. But the second model says, if they appear to be functioning the same, it's because the bilinguals are compensating, and therefore they actually have much worse disease. So we would expect their brains to be worse. Now, I've made this argument to rooms full of doctors and physicians and neurologists, and many times they don't understand. So feel free to say if you don't quite understand the logic. It's counterintuitive, okay? So if you're compensating, it means that actually you're dealing with much more disease, and you can only know that by looking in the brain, okay? Here's what happened. We had 20 monolinguals, 20 bilinguals, and we matched them on everything we could possibly match them on. These were actually patients at St. Mike's Hospital. Okay, those are CT scans of their brains. Now here's what we find. You go in and you do these little detailed measurements. And the first thing is you have to measure overall brain atrophy, because I'm sorry to say that as we get older, no matter how educated or bilingual or clever we are, our brains shrink. So there is age-related atrophy. We deliberately chose patients who were the same chronological age so that the overall base volume of the brain would be the same. We took 3 different measures of overall brain volume, and indeed, they're identical. So everybody in these 2 groups is dealing with the same amount of brain structure, brain tissue. Alzheimer's disease strikes a region right here in the middle of the brain, the medial temporal lobe. And the problem is the medial temporal lobe is where memory is housed, and so this is why the earliest symptoms are in memory. So the next set of analyses look at atrophy in the medial temporal lobe, because as these plaques and tangles take hold, what the CT scan shows is just atrophy, a black hole. So we have 3 measures of medial temporal atrophy, and on all 3 measures, the bilinguals are substantially worse. They have significantly more disease in that area of the brain. So everything looks to be the same between these monolingual and bilingual patients, but in fact, the bilinguals are coping with significantly more disease. So to sum up this part, our view is that the way that bilingualism works is by creating a long-term stimulating activity that enhances these executive control networks, making them available for compensation even in the face of disease. So it's brain exercise. All of these things have the effect of keeping those networks active and therefore functioning. So even when bilinguals have more disease pathology, they're able to cope and continue functioning at a higher level. I believe this has a lot of social policy implications. The thing is that Alzheimer's disease and dementia are diseases of aging. So we don't have to cure them in the sense that we have to cure cancer. What we have to do is prolong people's ability to cope with them, because as they're late life diseases by and large, people will die from something else that's unrelated. So the main agenda should be to keep people cognitively healthy so they can cope with these diseases. Or it's a more tractable goal than curing Alzheimer's disease. Now, in the GTA, 50% of families don't speak English at home. This is a gold mine for cognitive reserve. Just keep speaking what you speak. You know, you can assimilate your family and your children seamlessly into Canadian life without giving up on heritage languages. And I think there are many reasons to preserve them, and I hope you agree this is one. Okay, so that's my pitch for bilingualism, and I thank you for listening.